Hello there. Today we'll be doing the problem called zero matrix. In the zero matrix problem, given a two-dimensional matrix of integers, for each zero in the original matrix, return all values in its row and column with zeros, and return the resulting matrix. So, in example 1, we see a matrix, and if you can see this thing here, where we have, let me get some marker. We see this is we see a 0 here, and we some zeros here, right? These rows and columns becomes 0. And same for this. And this one. And so these becomes 0 too. As you can see, this 0 is here, so this becomes 0 as well. And you see these are 0 and these are non-zeros. Right, so how do we solve this problem? Well, one way is to look through the entirety of the matrix. And what we do is that we mark everything as -1. After marking everything as -1, we mark everything that was -1, 0. That is one way to do it, but that's not the best way to do it. Instead of using the memory as in the matrix as our memory by changing the non-zero numbers to -1 numbers, we could also incur the issue of possibly having a -1 in there. That was already a -1 before we made it a -1. We could save the row in a set and the column in the set, and by saving those items, we will do less processing because it's in a set and we process the row only a single time rather than multiple times. Also, using a set, we could generate entire rows of 0 rather than like going through each particular item at a time. Of course, we have to still go through each item for row columns. Well, that's the method I'm going to use. I'm going to look for all the zeros in the matrix first. So that's O of n squared times n times n times. Well, in this case, it's a matrix, so n times n. The row and columns should be the same. And get the set of rows and columns where zeros exist. Then for every row, I will create zeros for that row, and for every column, I'll create zeros for that column, and we'll return a matrix. All right. So first thing we do, create some sets. Then we're going to create our number of rows, number of columns. We'll be using this a whole lot. Number of columns will be the length of the matrix, and number of rows will be the length of matrix. So this is the length of the matrix, so each one of these are rows. And columns would be the first item, and we'll take the 1, 2, 3, 4, 5. So that's columns. Alright, that's done. So for I in range, num rows. For j in range, num columns. If matrix I and j is equal to 0, num 0 index row is equal to, well, dot add I, and 0 index column dot add j. So if that's done, we're going to go through for I in range. Well, not the range, for 0 index row. Matrix I, so that particular row, is going to be 0 of num columns. And now we're going to go through each column, 0 index column, and matrix for I in range of num rows. So get every single row and set that to 0. Return matrix. Let's run it. Oh, whoops. Let me shrink my screen a little bit. Okay, sorry about that, but we have the answer now. And looks like it was accepted. Let's submit. And we have a success. We have successfully answered the question. Sorry about that again. Let me just bring it right here. So let me review what we just did because my face was all over everything. So we created a 0 index row, 0 index column. This is for sets. To store where the zeros are for each row and column. We created the length of or number of rows and number of columns. Then we use that to iterate the n times m here. And for this particular set here, to get all the 0 index rows and columns, because we need to just access the entire matrix to find all of those zeros. Then we looked into the set and got all the rows and set each row that was 0 to the zeros. Then we set each column that was zeroed out to be 0, and that's it. If there's nothing else, if you have any questions, please comment below. If you enjoyed the video, please like, and if you want more, please subscribe. And you can always find more about what I'm doing in the description below. Alright, thank you very much. Have a good one.